Everyone, we're just getting started here. We've got another minute or two to go. So if anyone has a question before we get started or something that they'd specifically like to see in this presentation, go ahead and try to enter that question in now, and so we can make sure that feature works. Most of the other questions we're going to hold till the end, but it'd be good to get started. And by the way, this is Matt Navarre, so I'm going to be talking about search today and bringing web technologies down into FileMaker.
Okay, let's see. We've got two questions that have come in.
Great. I don't see them. Can you read them?
Yes. Rebecca Johnson is asking if this is FileMaker 13.
That's a very interesting question. I was playing with this in FileMaker 13, which just came out today. Obviously, when we scheduled this webinar, we had no idea that FileMaker 13 was going to ship today. All of the stuff that we're going to talk about certainly applies to FileMaker 13, and I will be talking about some of the features and capabilities, but I wasn't actually going to be using FileMaker 13 to present it. I wasn't quite that bold. Close. I almost did, but I decided to switch to 12. What was the other question?
I'm not sure what this question is. It has a URL in it, but no specific question. Laura, if you could repost a specific question, that would be wonderful. And Rebecca says thank you.
Oh, good. Well, it's time, so I say we start.
Okay.
Welcome, everyone. My name's Matt Navarre, and I'm going to be talking about some of my favorite technologies that I love in web browsers and how to bring these capabilities down into FileMaker Pro solutions that we build. So I'll delve into a few of my favorites and show some examples. Some of the examples will be in canned files, and some of them are going to be in actual live customer solutions with users logged in. So to start with, let's talk a little bit about me. So I've been a database developer for a really long time, since 1983, and have been doing FileMaker since the very beginning. I'm FBA Platinum. I'm applying to become a FileMaker trainer, and I'm certified in all the different versions. And primarily the last several years I've been working with public health in the state of Oregon and applying a lot of the things I've been learning and researching to the public health world. I run the Portland FileMaker user group for developers and also do the FileMaker Talk podcast with Matt Petrowski. Just today we recorded an episode talking about the FileMaker 13 and all the new features. And I have several hobbies that keep me motivated. I play guitar and I build guitars. So these are a couple of the guitars that I have, and I'm also a photographer. This is a photo that I took a couple years ago when I was in Africa that I really love how it turned out. Another picture those are my nieces. I really like how that turned out too. So as we start here, I'm going to talk a little bit about sort of some of the search features and what kind of things we'll see. So we'll start with just a quick demo of the current beta version of the FileMaker search results product that I have, and what its features are. So the main thing here is that this is driven by a single field search in the corner, and because that's kind of what we're used to in a web browser. When you do a search in a web browser, you go to Google and you enter into one field and you do your search from there. So I'll put something in like a company name, Enterprises, and I'll get a list of all the different companies that match that particular thing, ABC, BC, Burwell, and it's kind of too many. So if I want to get it broken down to a smaller number, I can type in another search, which is typically what you would do, and it could be in any order in Google. I'll type in Will, and that will refine the search and only show me the things that match just that. So I get Will Wheaton Enterprises, but I also get matches from other tables. I get contact names. I get contacts a couple of different ways. And so the thing that's important to see here is it's searching across multiple tables and with multiple types of searches being done. So it's finding a contact by name, and it's also doing an OR search to get even more different contacts. This also can search on phone numbers, so I can type in a phone number with or without an area code, and it does a search and shows it to me no matter how it's stored. I can search on a number that is a decimal number, so it could be like an invoice amount or an ID for a company, so it shows me different things for that. If I put it in with a dollar amount, it kind of, it can search and know that that's actually for an invoice where the dollar amount is $1,234. It can search on parts of a name, so if I do something like Robert Smith, and I don't actually have a Robert Smith, but I have a Bob Smith, it'll find Bob Smith, and it knows kind of how to do that. So Google, we're totally used to understanding how it does all these things, but they're kind of a mystery for FileMaker, because in FileMaker, usually what you get is no results found if you try to do a search for something that doesn't really have anything that could possibly match. And that's something that I submit that users really don't want to see. So let's talk a little bit about how those things are done and how to bring some of these things down. But there's much more that we're going to be talking about. There's really three things that I'm going to hit on. One of them is web history, which is the ability, like in a browser, to go back and see all of the different websites that you've looked at. So pages within certain sites. So like, if you've looked at particular pages of products in Amazon, when you go to your web history for the day, it'll show you, oh yeah, earlier today you were looking at this particular, printer, and you couldn't remember what it was, and you couldn't remember even to search for it, but you can see that you visited that particular page and read that information. It's very, very useful. Another one is relevance ranking, and that is when you do a search, how do you see the records that match more closely to what you want? So when you go do a search in Google, it is very, very good at showing you the results that are the things you really want to see. And then lastly, search, like just sort of building on not only just relevance ranking, but more detailed and more involved search where it can search across multiple tables and do other deep things about that. And to pick that apart a little bit and get some ideas of what we can implement in our solutions to bring that down into our software. So 5 things that I think that users should really do are take a look and watch users. When it comes to doing a search, another thing that I think is really important, really these 4 kind of work together when you're doing a search, and we saw that a little bit in the demo a minute ago. It pre-processes, which means look at what you're typing in before you actually do any kind of a search. It iterates, which means if it doesn't find what it's looking for the first time, it digs a little deeper and tries some other ideas until it finally shows records. It searches not only just on the one table that you're in, which is the way FileMaker normally would work, but in multiple tables, and then it concatenates and joins those results from all those different places into one page. So first of all, study users. What do we want to do there? Watch them at their desk. Watch how they actually use software that we write. See if their first attempt to find something, what they're thinking is the most native way to find something, actually yields the thing that they're looking for, and try to make the software work the way they want to work. The really important thing, I think, is to really not interrupt them, but just to let them do it and not guide them, but really sort of, without coloring what they're trying to do, watch them work and then take notes. I think it's really important, not only just in improving how users search for things in the database, but also how they just use the database in general, because I think we can learn a lot and make our system much better. Another thing that I do very often is I make a log of the different searches that users do, and then I periodically look at that and look for patterns to see, in this software, are people looking for names? Are they looking for customer IDs? Are they looking for invoices by date? Are they looking for, how are they searching? And is there a rule? Is there like, are overwhelmingly in this solution people looking for names, or are they overwhelmingly looking up by phone number? You know, I want to kind of follow that, and I want to make my software work really, really good for how users are actually using it. So let's talk a little bit about web history. This is the first of the technologies that I really kind of want to show. So web history, I also label this recently viewed records. So it shows a list of records that you've looked at in FileMaker in different tables and then puts it onto one page. So it used to be that a back solution was kind of the thing to do and the thing to have in a FileMaker database, where a user could sort of navigate through the solution and hit the back button, back button, back button. But I would submit that a web history is more useful because it survives logging out and logging in. It only tracks things that are really important, because you might want to go back. You know, very often you want to go. Going back would go to 2 or 3 screens you really don't care about, but there are certain screens that are really important, and that's what is good about the web history thing. I'm going to talk about what is actually involved in adding this to a solution, and then how it actually works. So let's leave this slide here, and I'll do like a quick demo of what this is first, and then we'll talk about the pieces and parts of how it happens. So let's see. This is some software I have called Reuse. It's a database that I wrote for inventory tracking and to run a surplus warehouse for the state of Oregon. And notice that what we're looking at here is properties, agency records, transfer records, and invoices. And to view any of these records, I can just click on it, and it takes me right to the detail of that record. And so I can see this is a void invoice for GSA Auburn. If I go back home, now that record is at the top of my list because it's the most recently viewed record that I've looked at. If I click on this agency, Bandon Fire Department, I'm looking at that. So this just kind of keeps a list of stuff that I've looked at in view order of when I've seen it. And I can scroll down and see records that I've seen quite a while ago. And then I can choose to keep this list really long or short. You know, in other words, I can cut it off at a few hundred records, or I can have it go thousands of records. And how did I integrate this? Let's go back to the slide and talk about what the pieces and parts are here. To do this, I added one table with 5 fields to my solution. And that one table is basically what we're seeing in that portal that shows me the date and the name of the record that I viewed. I have a relationship from my main menu or from wherever I want to connect it that shows me all the records in that table. And I track record views for just the tables that I really care about. In that particular solution, it's 4 tables. And what I do is when I view a record in any one of those 4 tables, and I consider viewing a record looking at the detail screen, not merely looking at the record on the list or in a report, but actually clicking on the detail screen of the record. So for that database, that's what I would consider a record view. And I have a trigger script that runs on record load that writes a little bit of history to track that I did see that record. And it does not modify the record that I'm viewing. It only tracks that in the history table, and I think that's also important. And then I'm looking at a list of the records that I looked at on the dashboard that's unique to me. So it shows me just the records I viewed and when I viewed them. The list of fields in this table that you add are a UUID, which is a universally unduplicatable ID. It's that really long ID that's a native feature that came in FileMaker 12 that you could do with custom functions before then. A text description of the record, which is like Bandon Fire Department number 263 or whatever that's going to be. And the name of the table that I viewed the record in. Also how many times it's been viewed and when it was last viewed. Those are the 5 fields. So to pick that apart a little bit, so here's my portal here, and this portal is called Menu Last View. So I'm sitting at my menu table right now, and I'm going to open up my graph here, and I'll take a look at Menu Last Viewed. So this is the table occurrence right here, and this is based on the last viewed table, the record history table. And in my menu, I have a text field, and it's a return separated list of UUIDs that then relates to the UID in my menu last view table. And so it's a global. So as I'm working through the system, to view these records, I have a global that I populate with a list of these IDs, which then shows me all of these records. So let me just add that so you can kind of see what that is. I'll put a table here, or a field on this layout, and it's called records, recent records list. And then all that is a list of those UUIDs. So if I were to clear it or cut it off, it would actually shorten my list greatly, which I can do just for demo purposes so you can see. Oh yeah, this solution is actually hosted on the internet, and I'm on it's on a server in another state, so it's taking a second to write the layout out here. And then each user would have their own list of globals. So let's say I'm just going to go ahead and clear this all the way out right now. So if I delete it, now I have no records on my list. If I then do a search for a record here, like test property, and then I look at a list and I look at some other property just by clicking on it randomly. How about this one, a tenor trombone? They get a lot of musical instruments in the surplus warehouse. It's kind of interesting. Those two records are now on my list. And then the two UUIDs for those records are showing up right there. I'll go ahead and delete that off the layout and commit that again. So the other thing that's really important is, and let me take a look at that on record load script. So if I go back to my list, and I'll look at another record here, I'm going to click on this palette jack, but before I do that, I'm going to turn on script debugger so that we can see what happens when I click on that. Oh, I skipped right past it. Here we go. On record load property, you can see my little developer notes in here too. So these are the important steps right here. So there's a table occurrence that connects my property record to my last viewed record that increases the count by 1. It tracks the last viewed date. It tracks the table name. And then there's a little bit of code here that I put in that's sort of how I want to identify the record on the list. So let's take a look at that real quickly. And so it's really just the ID number of the record, the line number, and the description of what that record is. And so that's really simple, and this would be about the only, these two are kind of the only unique things that you'd set for each individual table. The other stuff that I have down here is for different purposes. And then the other thing that's important is right here. I'm increasing the recent records list by just adding itself to it. So whatever the list is plus the UID of the record I'm looking at. So I have this little script on record load for property. I have one just like it for invoice and for my other tables that I'm tracking. And that's kind of all there is to it. So the other thing that you'd see is each of those other tables. So if I take a look at property here, here's property. I have a connection from property to last viewed, and this relationship allows creation of a record in my last viewed table, because if this record has never been viewed before, a record would need to get created to track it. And then at that point it would automatically update the ID. So that's kind of it. So I have one extra table occurrence for each table that I want to track, and then one table occurrence on my menu that lists the records that I want to track, which is this one right here. And one small script that I run on record load, and then from that I get the ability for each user to track their history. The other thing that I have here is if I take a look at my my portal, I've sorted my portal by the last view of the record. And I have some extra credit features on here as well. Over on the right, I have some conditionally formatted objects that show me with dots, kind of like the iOS 7 signal strength meter. And I'm looking at the view count field that I store, and I'm color coding and populating these little dots to show how often the record has been viewed. So I can see this one here has been viewed. There's 2 little dots on it. This one has been viewed 1. The other ones have no dots because they've only been viewed 1 time, so they're very low signal strength. So if I keep clicking on a record and keep upping its view count by going back and forth to list and keep upping its view count here manually, eventually when I get to a certain threshold, 3 dots will appear. And I've set those numbers to be, I don't know, 1, 5, 10, 50, something like that. So depending upon how often records are viewed, you can do different things there. So that's basically how that feature is integrated. It's really simple, and there will be a demo file that I'll make available to anybody who'd like that. By the way, I also should mention that my slides will also be available to anyone who wants them. The next thing that I wanted to show here is relevance ranking. So this is related to a search function. And the really important concept here is when a user does a search, they're typing in a particular search term, and then they're clicking on a specific record of a set of records that match that particular search term. So they may have done several different searches. There was a search session that happened, where they did a search, did another search, did another search, and then they finally clicked on a record that was the one that matched. So this is how Google does so much of its magic. They have a lot of ways that they can cheat, but so what you've got is you've got this search session, you've got a short click versus a long click. What that is if the user does a search for like Robert Jones and then they find nothing, and then they do a search for Robert Smith and they find nothing, and then they do a search for Robert Matthewson and then they finally find the record, the clicks that they do to try to look at the detail in between all of those are short clicks. So they do a search, do a search, do a search, do a search, and then they finally find the record that they want, and then they go away for a while. That last one is called a long click. And that's really important to track that time, because that long click, that very last one, is the important thing. And the really important thing to connect is the first search they did, which is what they thought was going to show the record, and the last record they clicked, which is what the record actually was that they wanted to click. So the other really cool thing about this is it learns over time because it's storing the association of these records from how a user is doing a search to what they're clicking on. So here's kind of a scenario that I was just laying out. Let's say that Barbara Jones recently changed her last name. So maybe she recently got married, and her name is now Barbara Peters. Actually, her name is now Barbara Jones. Her name used to be Barbara Peters. And so if a user searches for Barbara Peters, they would find nothing. And that would frustrate most users. But then they go, oh, that's right, she got married recently. Maybe she took a new last name. And so then they do another search for just Barbara, and they get a whole bunch of records. And then they go, oh, yeah, that's right, she works for ABC Technology. That's the one that I want. They click on her record, and then they start viewing her record. They call her back about her invoice or whatever. So that scenario, I think, is a really, really common scenario in search. And let's take a look in a little bit about how that actually works and what you'd have to do to integrate that into your solution. Just like the web history solution, this can be added to a solution by adding just a single table, and also which has just a handful of fields. So it would need to track 2 text fields, which would be the search that the user originally did, and then also the record that they finally clicked on. So the search record is the actual search term they typed in, and the text description is just sort of what we saw in the web history. It's a short description that you connect of the records that they clicked on. And then it would also want to track the table name and the UUID and a vote counter. So if they keep clicking on that same record, it gets voted up. Another scenario that you can kind of think about here is there's an actor who's been getting notoriety lately, Benedict Cumberbatch, and a lot of people make fun of his name because it's really out there. He's a really great actor. He was in the Sherlock series, the BBC Sherlock Holmes things, which was great, and then he also was in the Star Trek movie, which he played Khan, which is pretty cool. So, but his name is kind of funny because it's just so hard to spell, because Cumberbatch is not really a common word. So if you search for him in Google and you type his name wrong, Google will figure out, because he's got so many people looking at his information, what you meant to type. And they don't do that by having an algorithm of different ways to spell his name. They do it by tracking when people type the name incorrectly, and then they try it again and again and again, and then they finally find the site that they want to click on with his name spelled correctly. They're making a connection, and they're saying, oh, did you mean Benedict Cumberbatch? So that did you mean thing in Google is really kind of what we're trying to get to here. So what we do is when the user does this, when they actually click on the record that's the one that they meant to do, what I'm doing is I'm creating one or more records in a table. The important record that I do is I track the initial search term and the record that they clicked on as two field values. But it's possible that the user did multiple searches. And I might want to actually connect both of those things together. I might want to track the initial search they did and the record they clicked on, and also, excuse me, and also the final search that they did and the user that they clicked on. I would submit that the final search that they did was actually a lower quality match than the initial search. Then secondly, and very, very importantly, this table, which tracks this relevance, which tracks these record views, is the one that I'm really searching against. So I search here before I go look in the name table, for example. So let's see. This is another aspect of relevance, and then I'll get into the demo here of exactly what we're talking about here shortly. Some other concepts that I think are really important with relevance ranking. There's sort of two ways you can measure it. One of them is the inherent quality of the record. In other words, with that Benedict Cumberbatch example, the record that actually gets viewed a great deal of times is inherently a high-quality record just because it's been looked at so much. For example, if you've got two companies with really similar names, and one of them is your biggest customer, and the other one hardly ever orders from you, or did once 5 years ago, you would really want to see in a search, you would always want to see your biggest customer on the list first so that you don't accidentally click on the one that's the wrong one. The second concept, which is a little bit trickier, is when you do a search, to take a look at the search terms that you've typed and match them to a list of keywords in the record that you're looking at. That's really processor intensive because it uses a method of probabilistic matching, where you have to compare many to many, and it's quite involved. We won't really get into that today too much, but I've done a little bit of research on that and played with it a little bit. There's some other techniques. I think the first one is probably going to be the biggest benefit. So let's take a look at how this works here. So I have this other demo file here called relevance, and in here I have a list of names. And so let's say that I'm looking for a person's name, Emma Syed, right? Here's Emma. So I go back to home here, and I'm going to search for Emma, but I remember her name incorrectly. I remember her name is Emma Jones. If I can type correctly. It says, oh, I didn't find anything. Well, how about just Emma? And that gives me all my Emmas, and here's Emma Syed. So when I click on Emma Syed, that will make, actually I didn't really know. All that I knew what happened was all of a sudden I saw Emma's record and I'm looking at it. And then I can just go back home and do another search. So let me try another one. Let me try Robert Mathewson. It didn't find any. By the way, here it said, oh yeah, now you've got some searches. This is tracking my long clicks and short clicks. Let me just try Robert. Let me try Bob. I got Bob Jones and Bob Smith. I can do a whole bunch of different searches here until I get kind of records I'm looking at. and I'm not really getting the results I'm looking for here because I'm faking out my demo, but that's okay. So when I click on my last record here, and what was my first search that I tried? Maybe I'll just take another look here. I'll go ahead and click on Jim Smith just to sort of do the sample. So what's happening is in my relevance table, these are the records that just got created. So when I did a search for Emma, it made a record for Emma that linked to the other record. And when I did the same thing for Jim Smith, I searched originally for Robert Mathewson. So that would actually be kind of an invalid link. So my Emma link is a valid one, and my Robert to Jim Smith would be an invalid one. So I would need to have some code to track this, which I don't, that's not, this is just demoware at this point. It's not really a shipping thing. It's an idea that I think is important and that I'm continuing to research and flesh out. But behind the scenes, this is actually what's happening with these. Let me mock up one more so we can kind of get another example of how this is working. Let me search for, here we go, we got Kathleen, and her last name looks kind of difficult to spell here. I'll put Kathleen Jones and it finds nothing. I'll put just Kathleen, and then I see her last name. I'll click on her. And now if I go back home and I do another search for Kathleen Jones, which is what I remembered her name used to be, it's going to say, oh, you searched for Kathleen Jones, but you clicked on Kathleen Faska, whatever that is, and so now if I click on that, it takes me to her record. So I've just taught the solution that if I do a search for Kathleen Jones, this is the record I meant to search on. And then every time I click on that, if I go back home and then do another search, even just for Cat Jones, it's still going to find that same record. And every time I click it, it's actually going to up my little vote counter by 1. So now I did a Jones K, it still finds her again. And I can still also find her by her full name by doing a search for that. And it finds her that way as well. But it finds her that way by searching in the person table, whereas the other search that I did, it was kind of subtle, but the results are coming up actually in a search results table, which is the table that shows previous searches that I've done. I'm not sure. I'm hoping this is coming across clearly in terms of what's going on here. So we can kind of dive in and see what's happening here, so we can see how these associations are being made and at what point these things are building. So we've already seen that we've got this search relevance table, and these are the records that I've just made for Kathleen right here. So I've made 3 records for her. My first search was Kathleen Jones, and I made a record for her actual record that I clicked on, and then also one for Kathleen, and then also one for Cat FAI, all of which link to here. So any search that I do is going to link back to her. So how are those happening? Let's go back and go back home, and let's try yet another example. So I'll pick another person here that I'm going to try to find. Ezekiel Athens. Let's use that one. These are all my fake names. I'll spell Ezekiel wrong. I'll spell it E-Z-Z-E, even though I know it to be, So I'll put an E-Z-Z-E Athens. I'm going to turn on script debugger so we can see what's going on here. If I run my search, what's going to happen here is it starts by tracking that I'm doing a search. So right now my search count is 1, and it ups that number. I might be skipping the relevant search to search deeper, but I'm not. Or actually, am I in this point? Yeah, in this point I'm actually doing my very first search, so I'm going into find mode, and I'm looking for the relevance table to see if I know this particular record already. And I did not find any results in my relevance table. We've got a found set of 0. So now it goes back out to my person table, and this is filed under iteration. So I try a search in one place. If I find no results, I try a search in another place. So now I go in and I search for, in the person table, for EZZE Athens, and I'll find nothing. So that script is exited. The user gets, oh, I have a third table, which is company. It goes to company, and it does a search there, and it also finds nothing there. So now it says, sorry, nothing found. So then the user would say, okay, well, now what am I going to do? Oh, I think I see what the problem is. I spelled it wrong. So now they're going to fix their spelling, try their search again. The first search that's going to happen is going to be in this metadata table, which is the relevance table. Goes to find mode. Now, in this table, I've never actually made any kind of a link from Ezekiel, so it finds no records there. But then it's going to go to my second table, which is person, where it will find the person because now I've spelled their name correctly. So there it is. There's the record. And as soon as it says the found count actually has records, so I found one record here or more than one record, it's going to exit and say, oh, okay, I've got records found, so I'm not going to continue. Now that I've got a person record, I'm not going to keep going down to company. So it stops, and then I'm looking at my record here. The next thing that happens is, oh, I finally found the person I'm looking for. So the last part of this is I click on this record, and it runs another script called click result. The context is there as the person table. It tracks what the search was that I originally did. It tracks my the record that I clicked on and how long in milliseconds. I'm using the get UTC milliseconds function in FileMaker. And now what it's going to do is it's going to say, oh, well, you've just clicked a record, so I'm going to track information about what you did. I'm going to go to my relevance table. I'm going to make a new record and say, the first thing that you searched on was Ezekiel Athens, or the record that you clicked on was Ezekiel Athens. And actually, I had made a little error because I did a Cat Jones search just before I did this. So normally that actually would say my initial search. So my demo was a little bit broken there. And then it's going to make another record, and this is going to be the one that's more useful. This is the one that I actually just did a search on. So now it's going to say, oh, there's Ezekiel Athens and EZE Athens. So this first time, it's actually making those two different records to say, if I do this particular search, this is the record I want to look at. And so it's made one correct link and one incorrect link. But the incorrect link doesn't really hurt because it's not something I really ever would see. But if I try the same exact thing again, so now my search count, let me actually go back home because that's where my search counter is. My search count is 0. So if I type in EZZE Athens, it finds nothing. And if I correct it, it finds something. And now I click it. So now I have made that correct record between EZZE and the other one. So if I go home and try another search with just EZZE, it didn't work, did it? I love it when things go this way. So let's take a look at what actually happened there. So in my search relevance table, I've got records here for, it actually didn't make that other search. I think I know what I did wrong there. Let's try that one more time. So if I type in EZZE, oh yeah, actually at this point I've got 3 searches. So it's just going to need to sort of clear that really. When I click on a record and then go back home, that gets cleared. So if I type my first search and find nothing, and then I correct my search and it finds something in the results table, when I click it, it should make a connection. But it didn't because this is demoware. All right, well, I'm going to give up on that. But we can see at least what should be happening here and what happened correctly in the other examples that I did. Was that it would vote up that incorrect spelling and link it to the record that I really intended to click, and then shows that record. So that's basically what's happening there. There's not a lot of moving parts. Just like in the other solution that I looked at, I'm showing a list of records that I viewed. So if I take a look at the graph here, I've got my menu with my recently viewed records. I've got my company table and my person table. Oh, my person table is actually just right here. And then I've got a relevance which links to the different tables that it can be connected to. So my relevance table, which is my the table that tracks these records of what I searched on to what I clicked, link back to company and to person. And that's important because when I'm looking at my search relevance here and I click on one of these records, this could either be a company or a person, and it needs to be able to link it correctly to one or the other. So for example, if I go to my company list here, and I've got a company, let's go wait on the list. These are people names, aren't they? News Herald. So if I go home and I search for News Herald Inc., that won't find it because it has too many words in it. If I shorten it to News Herald, then it does find it in the company table. I click on that, it makes my connection. I go home and News Herald is a recently viewed record. If I go to my search relevance list, I see the correct link. News Herald Inc. links to News Herald. And then I see what I've got going on there. So now if I go home and I search for Herald Inc., I get the correct record that I was hoping to find, even though the News Herald record doesn't actually have the word Inc. in the title. So that's how that works. Let's keep going. There's more to show. I've got 15 minutes, and I'll take some questions. So single field search is another really important thing, and this is a pretty deep and big topic. So what's going on here is you've got a bunch of websites that have done this beautiful work for us. You remember these great search engines, Excite and Lycos, Ask Jeeves. This is supposed to be funny. Of course, the really big one is Google. That's what most people use. Probably a lot of people also use Bing. They've trained users to search from a single field. You go to a web page, or it's just in the top right corner of your browser, and you do a search, and then you get the results. Users totally know how to do it. We can mimic a lot of those features in FileMaker. We consolidate the results, and we can get we can kind of predict what users are going to see because we know what they're going to do, and we can give them the results they expect. So I think it's really important to put this search widget everywhere in your solution in the same place, or you can just use the built-in Quick Find field that's in the menu bar in FileMaker. And this single search field, usually what I do is I use a global field, and I put a trigger on it so that when a user does a on-object save trigger, when they go into the field and they actually type something different or delete it, it triggers the script to run. And that script runs through these steps. So we saw this a little bit at our very initial introduction demo when we started. So the first step is it pre-processes the data. So it takes a look and determines what it is that the user just typed in before it goes anywhere. So Google does this with thousands of data types. We can do it in FileMaker with 10 or however many common things you're going to have in your database. For example, it could be an integer, a dollar amount. It could be an email address or a website address. It could be a name. It could be two words or 3 words or 4 words. It could be a phone number with or without formatting, or a social security number with or without formatting, which are different numbers of digits. So what you do is you put some code in that examines this particular thing that the user typed, and you determine what it is before you go looking anywhere. And the best example of this that I can find is in Google. If you type in a FedEx tracking number, Google knows exactly that that is a FedEx tracking number. They don't search the whole internet because they know that the format of that number is FedEx, and they only go to FedEx's website and show you the package. Very simple. You can also use this to do other things like have commands. So for example, in Google, you can type in math. You can type in 27 times 243, and it will come up with that math for you, as opposed to doing a search. So, or in FileMaker, you could type in quit or recent invoices or something like that. So the function that I use, this is obviously really small text here. This is part of the function that I've written called data type. And what this does is it determines what it is that the user is typing in to try to get different types of data. So is it a phone number, is it an email address, etc. So the next step that you do is after you actually get the data type and you say, oh, well, the user just typed in a number. They typed in 1, 2, 3, 4, 5, 6, 7. Now I'm going to go searching. And so iterate is the next important thing. So what you do here is you try never to show the user that nothing was found. It's really important. You start with a search that perfectly matches what the user typed in. So if they type in 1, 2, 3, 4, 5, 6, 7, it's a 7-digit number. You start with a search that's exactly matching that. You'd say, oh, well, that might be a phone number, so I'm going to go into the phone number field and I'm going to do a search for that without any formatting, which will fail because data in your system may be stored, the area code. It might be 213-123-4567. So you gradually try some different searches by saying, if no records are found, you go back into find mode, you modify the original search term. You say, oh, it's a 7-digit number. Maybe it's stored as 123-4567. So you modify your search term by putting a dash in, a hyphen, at the 4th position, and then you do the search again. And if that finds records, then you display them. If it doesn't find records, you say, okay, well, how about if I try it in any area code? I'll put a star 123-4567 and then see if I find anything. That usually will find records. And in my little demo, let me actually show you that again really quickly. If I just type in those digits, it's going to show me all these different things. But if I look at these records, the phone number is actually stored with a dash. That would never normally even find it if I did it the other way. So here's another number, 842-2802, and that's stored with dots for whatever reason. So if I go to 842-2802, it actually didn't find it. Maybe I remembered it wrong. Here we go. If I put it in with a dash, because now that's actually a better cue that that's not just a 7-digit number, that it actually is a phone number. It finds it even though the area code is 800. And then I click on it, it takes me to that particular record, and there's the information. So it's using two things there, the data type and the iterate, to try to determine what I did. And by the way, if I go to my data viewer here, I have a whole bunch of different variables that I write. And one of them is data type. That's our data type right here. That says it's a phone number. So if I leave this running and I type a couple of other things in here, like 1, 2, 3, 4, that's just going to be an integer. So if I go down to data type, I was right on it. Here we go. That's just an integer. And so as I type different things in there, it's going to know that they're different things and then treat them as such. A couple of other more advanced things you could do is you could use a soundex function, which if you don't find a name based on the name like Robert, there's a function called soundex which compresses a name into the first letter and then a series of numbers that make consonants and vowels sort of compress down so that you can store a soundex of a name and then search on the soundex of a name, and then it will find matches much more loosely. It's a really interesting way to do it. I'm not going to be demonstrating that today. Another really good thing to do is to use the quick find function. So there's not only is there the quick find feature that you can just use on the top of your layout, but you can take something that you've got in a variable, like your single field search that the user typed in, and you can use the perform quick find script step on multiple different layouts to try to find records, which is pretty cool. Another interesting thing that I've done is I've fixed a lot of common date errors. So if I'm looking for a date and I know that I've got a certain date that exists in the record, but I type it in and then maybe it's stored wrong. So maybe I've got a record that is in the database and someone's date of birth is 1/17/1984, but I typed it in and it didn't come up for some reason. A date is actually a few different bits of data. So there's a month, day, and a year, and very often on date of birth there's certain errors that are made. It's very rare that all three of those are going to be messed up and that it's going to be stored 2/18/85 or something like that. Typically, if it's going to be misspelled, it's going to be one of those three things will be wrong, or the month and the day will be reversed. So 4/5/13 becomes 5/4/13, or just the day is wrong. So you can try a small series of additional searches on a date. For example, if you try my first search, 1/17/84, and no records are found, I can have a scripted search that says, oh, well, let me try *1784 to find anybody born on the 17th in 1984 in any month, or anyone who born in 1*84, anyone born in January of 1984, or anyone born 1/17/*, anyone born on that particular day in any year. And then I'd get those three additional searches would probably yield a small set of records. Most likely one of those records is the person I'm looking for. That would work really, really well if you have maybe 100,000 names. If you've got 1 million, then you're going to get way too many results and it's not going to be probably a good method. But that kind of idea was when sort of a light bulb went off in my head of other ways that I could sort of allow users to type things that aren't exactly precisely right, or to get around data entry errors, and still allow the users to find what they're looking for in the software. And I think that's quite important. Email is another interesting example. If you just search for an email address, FileMaker has that @ character protected, and you can't do a search on it because the @ character is looking for something specific there. However, if you put it in quotes, it'll automatically just do that search just fine against the whole email address. So, and there's other solutions that work around that as well. And the user won't know to do that, but you can do that in your script by sensing that there's a single @ and at least one dot, and it ends either in .com or .net or .org or whatever. And therefore it is an email address. And then you can say, oh, it's an email address, I'm going to put it in quotes, and I want to search only in the email field. So let's see, we've done a little bit of demos already in search results. And we'll get back to that in a minute here. The other thing that I think is really important is searching multiple tables. So not only do we do a search in just the person table, if you think about most search in FileMaker, it really just searches in one place. If you're sitting in person and you use Quick Find, or you go to find mode and you type in part of the name, you're really only in one spot. But very often what the user wants is actually in a different spot. Let me just quickly jump into something to sort of show one other thing about this. So on this typical layout right here, I can go in here and go into find mode and type in Minneapolis. And I do a search and it finds all my records that are Minneapolis, and I've got 3. But I can also go down to my phone field or my email field, and I'll put in 1, 2, 3, 4, 5, 6, 7. And on this particular set of data, it was pretty fast because it's fairly small. But that field, I'm sitting here in company, that's in person, and phone is actually pretty distantly related to where I am right now. It's over on my other screen. That's in company, person, phone. It's 2 tables away. And my sample file is pretty small. So I'm in company, I search to person, and phone is where it's actually stored, a properly normalized table that only has phone numbers in it. In a lot of solutions, that very, very innocuous thing that a user would do would yield extremely slow searches. So a much better way to do that is to actually navigate to the phone table, go to find mode there, do a search there, and then when I come back or when I display that result, I can quickly go back to the record that matches that particular phone number. So not only does the searching of multiple tables show results from multiple places, but it also can yield really big performance by only ever searching on indexed fields within a local table. So it's pretty good. The trick then becomes, how do you get those records displayed? And there are many different ways around it. So there's been some really cool methods like Virtual List that Bruce Robertson put together up in Seattle. You could actually build an HTML page and show it in HTML and show it in a web viewer, which would be pretty cool. The way that I chose to do it is actually repeating global fields, which is weird, but it actually works. So in this commercial solution that I'm demoing right here, which is FM search results, I track I have a repeating global field that has, or several repeating global fields. One of them shows the little text description of the thing that I clicked on, and then I'm also storing the ID of the record I clicked on, and then the table that record lives in. And so those three key things allow me to really get a lot of extra information and to be able to navigate back to that result. So how does the display results work? So you can get list view, you can do portals, repeating global fields. It's actually nice that it's pure FileMaker, but it's a little tricky to set up, so that's why I did a lot of work on that. Let me jump into a quick demo of how that works here. So if I go into ABC, that's the wrong demo file. I go into ABC and I'll do my search, and it's going to show me results here from multiple places. So I can see ABC Technology, ABC Enterprises, etc., and then I also get contacts. So this little widget that I'm looking at right here is actually a repeating global field with 256 repetitions, goes all the way down the page there. And to really sort of see how it works, I've got another version of this. Let's see, add to your solution. It's in how it works right here. This shows what I'm actually storing. So let's try to do a little bit simpler search maybe. Robert Smith is a little shorter number of records to look at. So first of all, at the very top, I list recently viewed records, and that's a feature that I could turn on or off. And those are not in any table. But then when I actually start having results, I numbered my tables starting at 1, so I can have up to 98. And I see my company that matches, so I track the short bit of text that I'm just displaying, the ID of the record in that table, so that if I click on that line, I can go back to the record, and the record ID in that table. And then the same thing for the person record. So this particular company has an employee who works there, and here's the ID of the employee. That's actually table 2. So if I click on that, it's not going to table 1, it's going to table 2, which is pretty cool. And then if I have multiple contacts, it shows me the different contacts that also match my search. In this case, it actually did a search. It did a name substitution because it actually found Bob Smith, even though I typed in Robert Smith. So it's got some extra smarts to handle that as well. And then those are the IDs of their records there. And then when I click my button to look at it, it just says, oh, well, I clicked on record 15 or whatever that is. Go to record 15 and get the ID and get the table and then know how to parse it. That would be, maybe more than I would recommend anyone build for themselves. But that's how I did it in this particular solution. And it gave me the ability to easily paste something in, so you can add this software into your solution in an hour, and then you have this Google-style search as part of your software. So we're coming up onto the end here. In summary, I think it's important to watch what your users do, to think about what web technologies exist that are already done by web companies, and to not make your users adapt to your solution, but go the other way around. Break down your searches. Really think about things in small bits. Be atomic and don't repeat yourself. Write code in one place. how close can we get to what Google does? I mean, they're pretty amazing. We might only be able to get a couple of percent there, but I think we can at least start going down that road and get towards what they actually do. Make it fast. A user should never be waiting, 5 seconds for a search to run. It should be really, really fast. Test it on the environment that the users are actually using. Don't build solutions with small data sets on your SSD drive and then expect it's going to work the exact same way if your client's on a WAN, because it won't. I talked about optimizing for future unannounced products. That changes because today FileMaker 13 came out, and all of the things that I've shown today work not only in FileMaker 13, not only in FileMaker Go 13, which is new today as well, but they also work really nicely in WebDirect, which is the web-enabled version of FileMaker that replaces Instant Web Publishing. They work really fast because it processes those searches at the server level and then shows results. It's pretty nice. Here's my contact info. I'll leave it up here for a second so anyone can write that down. And then we've got a couple minutes left for questions, so I'll answer questions about what we've seen. For those of you at the JET, I'd also like to say thanks very much for your time today. It's been a pleasure talking to you about the things that I really care deeply about in FileMaker and bringing web technologies down.
Okay, thank you, Matt. We have actually three questions.
Okay.
The first one is from Dylan. I had to take a call during this webinar. Our recording's going to be made available. We did record this session, Dylan, so we can certainly provide you the file. If you want to, I'll make sure that Matt has it, and if you